All right, so today is the last day on probability. We're going to specifically be talking about two different pieces. One is about what are complementary events and how do we use that to determine probability. And we're also going to be talking about the odds that something should happen. Okay? Before we even talk about defining what a complementary event is, I think the easiest way to understand what a complementary event is to just look at an example of a complementary event. So, an example would be the probability that Lake Park will win the next basketball championship. There are complementary events happening here because there are only really two options. The two options are that either you win or you lose. Two options, right? You win or you lose. Both cannot happen. Both cannot happen. Maybe I should, instead of saying cannot, maybe I'll say both never happen. Okay, so I can't both win and lose the championship, right? Either I win or I lose. So they're complementary because there are only two options. In both of those options, you can never have both of those options happen. You cannot both win and lose the championship. And the other part that tells me that they're complementary is one must happen. So both never happen. So you can't win and lose. And the other thing is one must happen. In other words, you have to win or you have to lose. There are no other options. No other options. So that's the idea of complementary events. The idea that you win the championship or you don't. There are no other options. Either yes you do or no you don't. One of them must happen. Either you win or you don't. And you can never both win and lose. So that's really the definition of a complementary event. Complementary events means that you can never have both events happen. You can never have both events happen. And one must always occur. Or one must always happen. Okay? So in other words, what a lot of times they say about this is the probability that both happens is 0. So probability of both equals 0 because that can never happen. You can never have both, and you have to have at least one happen. Okay, so we talk about events being complementary. The two complementary events for this case was winning the championship and not winning the championship. So when we talk about things that are complements, the complement, not like in geometry when we're talking about adding up to 90 degrees, but the complement of an event equals the other option. So here it says Lake Park will win the next basketball tournament or the next basketball championship. The complement to that, the complement to LPHS winning the championship is LPHS. And this is going to be particular. Normally we won't say losing, we'll say LPHS not winning the championship. That not is key. So a lot of times we'll say something like, what's the probability of it being 80 degrees outside? What's the probability of it not being 80 degrees? Okay, those are complements of each other because it is 80 or it's not 80. You can't have both of those things happen. And one must always happen. Either it's 80 or it's not. Okay? And the way that we write it is this. So, when we're talking about a complement, the notation is if event is A, then the complement is written like this, A with a dash over it, and we read it not A. All right, and in the end, when we're talking about probability, since one of these happen to have to happen every single time, that tells me that the probability of the event and its complement equals 1. Because one or the other one must happen. So 1 is like saying 100%. So there's a 100% probability that both will happen because one of them has to happen. And we would write that as probability of A plus probability of not A equals 1. This makes finding the complement easy. So to find the complement, since they both have to add to equal 1, that tells me that I can just take 1 and subtract the probability that it happens, and that will give you the probability of not A happening. So we talk about probability of complementary events. If you know the probability of one, you can find the probability of the other one by just doing 1 minus that probability. All right, so for example, and to me this is probably one of the biggest things here, right? If the probability of a snowstorm in Arizona is 0.07, so probability snow Arizona equals 0.07, then what is the probability of there not being snow? So probability of not snow. Well, these are complementary events because either there is snow or there's not snow. So since they're complementary events, that tells me I can just do 1 minus 0.07, and the rest of that is the probability that there's not snow. So the probability that there's not snow in Arizona is 0.93. Okay, so if you can find the probability of one, the probability of the other one, if they're complementary, is just subtraction. So let's look at number 2. Okay, 2 cards are drawn from 2 separate decks of 52 cards. What's the probability of drawing? So we need to be careful here, right? 2 separate decks of 52. Right, so we have to look at this as here's a deck of cards and here's a deck of cards that we're doing. So this is like deck 1. This is deck 2, and we're going to draw a card from each one of them. 2 cards are drawn from 2 separate decks, so we're going to draw one from here and one from here. What is the probability of drawing a jack both times? Well, remember, probability is what you want, right? Divide it by the total options. So in this case, let's find our total options. So there are 52 options in the first deck, 52 options in the second deck, right? So my total options equal 52 times 52, which is 2,704. So right now we're starting out with 2,704 as our base. Now they're asking us, what's the probability that we draw a jack of hearts? So this is very, very specific. Not just any jack, but it has to be the jack of hearts. Well, if I'm drawing things out of the deck, a jack of hearts, I can only have one way to get a jack of hearts here, only one way to get a jack of hearts here. So there's only one combination that would give me a jack of hearts. So it's 1 out of 2,704. So this is the probability that I get a jack of hearts twice. Because there's only one combination that would give me a jack of hearts twice, and it's jack of hearts, jack of hearts. I could do jack of hearts and jack of diamonds, but that's not what we're looking for. So then the next part of this asks us, what's the probability of not getting a jack of hearts? So look, The only difference between this question and this question is instead of just saying Jack of hearts, it says not Jack of hearts. So this is like your probability of A. This is probability of not A, right? Because we're not getting a Jack of hearts. So if this is 1, either I get a Jack of hearts or I don't get the Jack of hearts both times, right? So I can just do subtraction. So this is really 1 minus 1 out of 2,704, which means 2,703 out of 2,704 equals the probability of not getting the Jack of hearts twice. Okay, the next one takes us a little bit further. It says, what's the probability, because right, we're starting out with that, what's the probability, because this is all part of 2, of getting at least one card that is not the Jack of hearts? At least one card that is not the Jack of hearts. Well, right now, isn't every other option but this option going to give you something that has at least one card that is not the Jack of hearts? So not the Jack of hearts, that's that same thing here. At least one card that is not the Jack of hearts. So this would be 1, 2, 2,703. All right, last one, number 3. A jar contains 10 balls, numbered 1 through 10. 2 balls are randomly selected, one at a time without replacement. And this is key, this without replacement. What is the probability that the 2 balls add to equal 10? So, well, first of all, we have to figure out how many options there are, right? Because probability is what you want out of the total. So I have to figure out my total options. Well, I'm going to draw 2 balls. So that means one of each, right? When I draw the first one, I have 10 balls, 10 numbered balls, so there's 10 options. Now the second time I draw, we didn't put that ball back in there, so there's only 9 options. So 10 times 9 means there's 90 possible outcomes. So right away, when we're doing probability, I know the bottom is going to be 90. Now I need to focus in on that the 2 balls have to add to equal 9. Well, if my balls are numbered 1 through 10, right, because it says they are numbered 1 through 10, then I need to make a list of ones that would add to equal 9. So if I drew a 1 and then I drew an 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4, and notice these are just reversing, right? 6 plus 3, 7 plus 2, 8 plus 1. I can't do 9 because 9's already equal to 9 and there's no 0 ball, and 10 wouldn't work either. So these are my options. So there's 1, 2, 3, 4, 5, 6, 7, 8 out of 90 ways to get it to equal 9, which reduces to 4 out of 45. So the probability that they add to equal 9 is 4 out of 45. Now we can use that information to do part B. What is the probability that the 2 balls add to equal not 9? So that not is important. I'm going to have you try this one on your own because I feel like this is the new topic. So try that one on your own and then go ahead and go to the next video.